Welcome to Buildings and Beyond,
the podcast that explores how we can create a more sustainable built environment
by focusing on efficiency, accessibility, and health.
I'm Rob Aldrich.
And I'm Kelly Westby.
In this episode, we're talking about electrifying home heating with air source heat pumps. This is not new. We've talked about it before. Many people, many programs are trying to encourage people to electrify their homes, eliminate fossil fuels as much as possible. This can make a big difference in CO2 emissions, which is the primary policy goal. In this episode, we're specifically talking about low and moderate income folks, working with low and moderate income folks to help them electrify their homes. You'll hear the abbreviation LMI, and that's what that stands for, low and moderate income. If you aren't familiar, you'll hear that a few times. In this episode, I talked with Jon Harrod. Jon is a home performance contractor and HVAC contractor in central New York. He started a company, Snug Planet, several years ago, though he is now merging with Halco, a larger HVAC and home performance company in New York State. Both firms do a lot of work in low and moderate income homes. Jon really knows his stuff. He really knows what's up with heat pumps. I learn a lot every time I talk to him. I also learn a lot from his blog posts. If folks haven't checked out his blog posts on Green Building Advisor, I would recommend that you do that. They are really informative. We can link to those in the show notes. My first question for Jon was pretty fundamental. Why are we talking about electrifying low-income homes? Not because equity is not important, but because heating with heat pumps doesn't always lower costs. Thank you for being here, Jon. I have to pause and scratch my head on making electrifying low and moderate income houses a priority. Because I see and I hear from weatherization folks, a lot of these homes are heated with natural gas, and heating with natural gas is still less expensive than heating with heat pumps, usually, often, certainly in the Northeast. Mm-hmm. So why, just big picture, why is electrifying low and moderate income houses a priority?
Yeah, so I think there's a couple things that are worth considering. One is that we're talking about a really big chunk of our housing stock. This is not a niche market. Low income is often defined as below 60% of the median income. And so you're looking at, roughly 30% of the population falls into that category. And so if we want to move our entire system towards low carbon solutions, we cannot leave the low income demographic behind. I think that the issue of cost savings is really critical in thinking through this issue, because low income households tend to spend a much higher portion of their total income on energy. And so if we don't find a way to reduce their overall costs, we haven't succeeded. And that includes, the cost of purchasing the equipment, the energy costs over the lifetime of that equipment, plus any costs associated with maintenance and repair to the system. So we need to think about all those costs and making sure that those are actually serving the interests of the people we're trying to help. I think that one of the things that we're seeing is that there are certain specific scenarios where electrification and heat pumps can save people a lot of money. And the big one in our area, which is rural upstate New York, is people who are living in rural areas and don't have access to the natural gas system. So they're typically heating with oil, propane, electric resistance, oftentimes supplemented with some solid fuels like wood and pellets and coal. all these fuels have a higher cost to operate compared to natural gas. And so they represent a place where we can really save people money.
And is that kind of your focus? On your projects, are you focusing on homes with delivered fuels often?
That is a big part of our market, especially when it comes to low to moderate income. And New York State programs have really focused on the delivered fuels as well as a starting place. So I think that's one market segment that can really be well served by heat pumps. Another one is people that are on electric resistance, and this includes a lot of our low-rise multifamily. These are, typically, 1 to 3 story apartments. They might have 24 to say, 75 units that are all electric. So they're already, quote, electrified, but their costs are very high. And so these can be helped a lot by, targeted application of cold climate heat pumps.
That makes sense. Yeah, for sure. And you mentioned, well, a couple thoughts. I'll go back to like the delivered fuels thought actually, because we did some consumer research for sponsored by NYSERDA, New York State, and we found that most people don't know anything about heat pumps, regardless of income level. Mm-hmm. The driving force behind people's interest in heat pumps is it cost effective? Is it going to save me money in the long term, regardless of income? It was really across the board, and it's a really good argument to focus on delivered fuels and resistance, like you were talking about. Do you see? You focus more on those types of homes, those types of systems. Do you see a larger trend? Are you alone, or do you really see electrification taking root elsewhere with delivered fuels, with higher energy costs?
Right. I'm in the process of joining forces, my company, Snug Planet, with Halco Energy, which is one of the largest HVAC and home performance companies in our area, and are also very committed to electrification. And I think between us, we are probably doing the majority of the low-income electrification work in central New York. Other companies, I think, have been a little bit more reluctant to jump on board. Some are advocating dual fuel solutions, which I think we should talk about. We've been leading with the cold climate heat pumps, going to 100% electrification. And so I think in our area, it hasn't seen widespread adoption, but when I listen to people from northern New England and the Midwest, I'm seeing a lot of adoption there as well. So I think it's coming. I think it's just we're at the early stages at this point.
Okay. You mentioned resistance in multifamily buildings. Are there different housing types that with low and moderate income households? Are there kind of distinct housing types that you target, or different from more market rate or higher income housing types? Is it a different focus on the buildings, like the type of building?
Our area has a really interesting housing stock in that we have kind of a history of architecture that you can drive around a town like Ithaca or Elmira and see examples of timber frame Greek Revival houses, Victorians, early 20th century colonials, ranches, and then more modern styles of housing. And we find that all these housing types also are present in our low to moderate income sector. So we see a lot of that there. A couple housing types that we see a lot more of when we're dealing with LMI customers are manufactured housing, and then although we've just kind of started working with these, the low-rise multifamily, which in our area includes a lot of elder homes and things like that, one bedroom or sometimes studio apartments.
Interesting. Okay. Are there particular challenges with those housing types, either on the kind of the insulation, the load reduction side, or on the heat pump side?
Mm-hmm. Each housing type presents its own special challenges. As we're talking about heat pumps, some of the things that come up again and again are panel capacity. Do we have enough amperage in the panel to fully electrify this house? Duct capacity. If we're looking at putting in a ducted air handler, is the duct system that was there, that was originally designed for fossil fuels, does it allow for enough airflow to make a heat pump work? And then there's the load reduction issues that you mentioned. In order to make a cost-effective heat pump system, we need to essentially get the load down somewhere in the neighborhood of 50,000 BTUs or below. And that can present some challenges, especially in some of these older Victorians and farmhouses, things like this that start with high air leakage and complicated geometry.
One of the lowest first cost heat pumps, heat pumps that works well in cold weather would just be a 1-to-1 ductless mini split. One outdoor unit tied to one ductless indoor unit. They can work really well in cold weather. They provide heating, they provide cooling. Is this, and I'm thinking install one heat pump. I'm kind of asking this question tongue in cheek, but look, here's the lowest cost heat pump you could install.
Yeah.
Is that viable in an apartment, in a manufactured home, in other types of low? Here, we'll install one good cold climate heat pump, use it for cooling, and try to offset as much heating as possible. Is that a viable approach?
I think there's a lot to be said for that approach. We can get, 1-to-1 ductless heat pumps up to 24,000 BTUs or larger. And the 1-to-1s are relatively quick to install. They have reasonable electrical requirements. They tend to have high coefficients of performance and a good modulation range. So in a lot of ways, they're great products. The main challenge that we run into in applying those is cases where they can really only serve a part of the house. You can make a meaningful dent in people's energy use by putting one of those in the open floor plan, kitchen, living room part of the house. It still means that they will need some kind of supplemental heat in the bedrooms, especially in very cold weather. One approach we've been looking into for the multifamily apartments, these are typically, something like 500 or 600 square feet with a common area and a bedroom, is just putting a single head in the common area of that space, and then using a through-the-wall circulator fan to move heat and cooling between the main space and the bedroom.
And as you said, a lot of those homes, a lot of those apartments are already electrified. A lot of them have resistance to start with. So that may be not a heavy lift. I mean, it may be the panel size might be okay.
The panel size is typically great because, we're taking out a baseboard circuit and we're putting in a heat pump circuit that has about the same amperage. It would typically be a 15 to 30 amp circuit. So we're not adding a lot to the electrical load of that apartment. And we also know that we have space in the panel. In one project that we're actually proposing right now, we're planning to repurpose the baseboard circuit, and instead of having it come into the living space to feed a baseboard, send it out through the wall to be a dedicated circuit for the disconnect, and that way we can avoid having to fish new wires through the finished apartment. That won't always work. It has to be, carefully engineered and sized properly and so forth. But there are cases where it actually is a very elegant solution.
I would hope that in an apartment that was heated with resistance, you install a heat pump, people use the heat pump. I'm sure that's not always true, but hopefully it's mostly true, especially if you take out the resistance heat in the living room and all there is in the living room is a heat pump. People are going to heat with a heat pump. Am I more or less accurate on that front?
Well, one of the things we're finding is that there's this customer education component, especially when you're trying to mix different heating strategies. What we find is that rural folks are often used to using a diversified heating strategy. So they might have a wood stove that heats the core of their house and space heaters that are a lot more expensive to run in the bedrooms. And so they're used to managing that. How well that's going to work when we're mixing, a heat pump and electric resistance in a smaller apartment, I think remains to be seen. There are controls that you can use to integrate heat pump with either fossil fuel heat or an electric baseboard. So far, we haven't dug too far into those, but I think that's going to be important in the future as we think about having the heat pump as your stage one and your electric baseboard as your auxiliary and backup heat. To have that automatically controlled, I think is going to give a lot better result than just relying on homeowner education that ultimately can break down.
Yeah, I've seen so many cases and heard so many anecdotes and actually read a lot of pretty big scale like utility program evaluations where they, a heat pump will get installed in a home that already has a hydronic heating system or whatever. And homeowners love it. It keeps their living room nice and cold. Winter comes, they turn off the heat pump and use the boiler for heating all winter. And, these evaluations bear it out. It's like they estimate how many hours people are going to use their heat pump. And, the run times are 25% of what they estimate in heating run time for heat pumps, because there's a big education issue, as you say, and that's what people are used to. And there's also maybe a comfort, there certainly can be a comfort implication. So you said you haven't dug into controls too much yet. I agree with you, but I also agree can be pretty complicated to tie several different types of systems together. For now, is education the answer, or are there other system designs, strategies, I guess either for low income or market rate, this is kind of across the board issue, that really work well?
Yeah. One of the things that I've gotten really excited about as what I think is going to be one of the things that really helps electrification scale is the fully ducted heat pump. The thing that essentially has the same form factor as a gas or a propane furnace, sits in your basement and heats either the entire house or the majority of the house, with possibly another ductless zone split off for a addition or a bonus room or something like that. That situation is set up so that the heat pump will act as the primary heat. You'll still have a electric resistance coil that will be there for extremely cold weather and will help buffer the effects of the defrost cycle. But essentially, it kind of steers people towards using this as their primary heat. It becomes a lot more complicated when you've got a ductless system and you leave the existing fossil fuel system in place. I think that's a place where we're going to continually run into, kind of backsliding.
So that's a great point. And I had this on my list of questions. Cost-wise, if we're talking about lower income households, maybe more sensitive to first cost, even though there are financing and programs, which we'll touch upon in a little bit. First cost is still a big deal. How much more expensive is a fully ducted system than one or two ductless split systems? I'm sure it varies.
It varies a lot.
Yeah.
But if you're looking at the cost before any incentives, the break point between ductless and ducted systems is usually somewhere between 2 and 3 heads.
Okay.
So a small fully ducted system might be under $15,000, and to do a 3-head system, either as all tied into a single outdoor unit or multiple outdoor units, is going to be roughly in that same range.
Okay. Cool. It's great. It's great to have, be able to put numbers on things. And I know pricing is going crazy with COVID, and it, if
Yes.
we go down, you're in central New York, and if we talk to somebody in Westchester, we're going to get some different numbers, or New York City. But that's a great point of reference. So thank you. On the ducted side of things, I mean, so many questions. When ductless heat pumps first came out, people raved about them because they don't have ducts. Mm-hmm. And in weatherization and home performance, getting ducts air sealed, sized properly, insulated, is just impossible. I mean, it's hard to get it right in new construction. And then, going into existing homes when half the ducts are behind walls, getting them tight and sizing them properly and insulating them well, it's such a big challenge. But it's kind of coming around. The limitations of ductless heat pumps for full electrification are also hard to ignore, as we've been discussing. So, I mean, do you have an approach when you go into an existing home with a duct system, how to make that duct system good enough to handle the heating and cooling with a new heat pump?
Yeah. The answer is that most of the time what we end up doing is taking a whole house approach. So we look at, are there cost-effective opportunities for insulation and air sealing so that we can bring the load down? And typically, the old fossil fuel system that we're removing was significantly oversized already.
Yeah.
And it will be even more oversized once we do the load reduction. So we might have had ductwork that was sized for, an 80,000 or 100,000 BTU furnace. And so to meet the airflow requirements of, say, a 3-ton, 36,000 BTU air handler is possible. We're finding that our, in terms of airflow per BTU, heat pumps require more than twice as much airflow as even a high efficiency fossil fuel furnace. So we need to make sure that duct capacity is high in our priority list. We can also look at targeted improvements to the duct system, not necessarily upgrading all the supply runs, but focusing a lot on the area right around the air handler itself, and specifically the return and the filter, because that's a place where a lot of resistance can be avoided by upsizing that return, using a thick pleated filter with a low pressure drop. And what we found is that most of the time we're able to get these duct systems to work well. When we go and test the static pressure after we're done, we find that it's within the target that we've been shooting for.
Nice. Cool. How about sealing? Do you have any strategies? I mean, do you seal if there are ducts in an attic or a crawl space where you can get at them?
Yeah. Attics require special attention because they're, for most of the time, they're outside the thermal boundary and they're a place of extreme hot and extreme cold. If we can make a case to encapsulate that attic and bring it inside the thermal boundary, we can avoid a lot of the losses from ductwork. We don't see as much attic ductwork in our area as I know that is common in downstate regions and as you go further south, and that's a good thing. With ductwork in with ductwork in crawl spaces and basements, our primary approach has been to try to bring those spaces inside the thermal boundary.
Cool.
And so that heat losses to those spaces still end up within the house. We still want to seal the ductwork to gain control of distribution and to solve air quality issues, but we don't worry as much about the thermal losses.
So one other question related to ducted systems, and you mentioned dual fuel. I think full electrification, if you can make it happen, is that's obviously everybody's kind of goal. That's kind of the carbon goal, the policy goal, and hopefully really for homeowners, if they have one heating system, that's kind of lower cost, lower maintenance, lower replacement cost when that has to go. But where do you see kind of dual fuel heat pumps? So, which is kind of a furnace plus a heat pump in one kind of appliance. Where do you see that being practical or viable or effective?
Yeah, I will say that, being a kind of, climate guy and electrify everything advocate, I was originally not a huge fan of dual fuel systems, and it's taken me a little while to warm up to the idea. For one thing, most of the dual fuel heat pumps on the market are not so great at colder temperatures. When you look at a lot of the equipment that's out there, its performance falls off pretty dramatically as you get below about 35 degrees. And so we're finding that we end up switching over to fossil fuels somewhere at that 35 degree level. Now, that being said, I think there are some real advantages to dual fuel systems. One is that I think that people that are skeptical of going all electric, this can reduce their resistance to doing that. It provides a level of redundancy that you don't have in a heat pump, cold climate heat pump that just has a single outdoor unit. So that if the heat pump portion of that dual fuel system were to go down, the compressor or the board were to fail, you'd still have your fossil fuel heat for backup. The downside is that you end up switching over, and depending on how you design the system, your switch point may be 35 degrees. If you really want to be aggressive about it, you might design it to work down to 25 degrees, but then you are going to end up switching over. How much of a dent that's going to make in your fossil fuel use is going to depend a lot on your climate. And the further north you get, the bigger portion of your heating season is below that switchover point. So there's pros and cons. I've been really intrigued by this idea that Nate Adams has proposed, that one path to electrification would be to incentivize manufacturers to stop producing straight air conditioners entirely, provide a incentive that he ballparked at $400 per unit for manufacturers to make exclusively heat pump capable outdoor units. And that way, every house would end up with that capability. Whether they wired it in or not would be another question. But it would essentially provide a mechanism to rapidly take advantage of that replacement cycle to get heat pumps into every house that has a central air system.
I hadn't heard that suggested before. That's interesting.
Well, it started out as a Twitter thread, and then started getting some serious traction in the policy world. And I think it's a pretty intriguing idea.
Yeah, it's ambitious, but it's certainly something to think about. I'm gonna have to kind of mull that over. Yeah, that's pretty interesting. So do you install dual fuel heat pumps, and if so, kind of where?
Yeah, so we do install them. Right now, we work a lot under New York State programs, and those programs are really geared towards cold climate heat pumps. So, things that perform well at temperatures, well below 15 degrees. They're on the cold climate heat pump list for the National Energy, or the Northeast Energy Efficiency Partnership. And so the state and utility incentives in New York are really steering us towards those cold climate heat pumps. There are cases where the dual fuel system makes more sense, either based on the customer's comfort level or the fact that the costs of the cold climate heat pump for their particular situation were just put it out of the range.
Okay. What are some? I mean, we've been talking in generalities. Can you give one or two examples of just really good success stories about electrifying lower income households? I'm kind of putting you on the spot. I didn't ask you to kind of prepare any examples, but do any kind of come to mind readily?
Yeah. So just to give a couple examples of a couple of the projects that we've been doing on a regular basis. A lot of our rural housing in New York is manufactured housing, and
which for a lot of people get it confused with modular. This is manufactured as, quote, here I'm doing air quotes on a podcast, trailer type homes. That's what kind of manufactured refers to. I hear a lot of confusion, so I figured I'd jump in and say that.
Yeah. So they're built in a factory and delivered to a site on wheels, and they may or may not have a permanent foundation. And this makes up a big part of our rural housing stock. A lot of these are heated by propane and oil, and end up being very expensive to operate. So one of the things we've done through this heat pump pilot program is come up with a solution for these manufactured homes. What we found works really well in these situations is to take advantage of the existing ductwork, which is typically quite undersized. And so we use that to serve just the kind of bedroom and bathroom wing of the house. We use a air handler that's converted to downflow configuration. We have some custom duct adapters that we have in place. And that way we get heat into each of those individual rooms. And then we use a larger ductless head, usually a 1.5 ton ductless head, to serve the open floor plan at the other end of the house. And that's been, I think, a pretty popular solution. We're just started doing these within the last year, and we're looking to, evaluate actual energy savings over the course of the year. But we feel like there's a lot of promise there.
Cool. So happy customers, lower costs.
That's
so far?
Yes. I mean, all
Okay.
subject to our follow-up monitoring, but so far the feedback has been very good.
Awesome. Cool.
And then another approach that we really like is kind of a comparable approach for a 2 or 3 bedroom ranch that's on a permanent foundation that might have just had electric baseboard. And there, again, we like to use a ductless high wall head in the common area and a compact air handler, sometimes referred to as a pancake air handler. These are the flat ducted systems that some of them can only handle a small amount of static pressure, and others are designed to run at higher levels of static pressure. To provide ducted distribution to the bedrooms and bathrooms down on the other end of the house. And one of the things I really like about this is that we don't end up having to put individual ductless heads in each of the bedrooms, where they'd be really oversized, oftentimes kind of physically just a major presence. And we can better match the load of these rooms to the output of the heat pump. So that when the heat pump modulates down, it's not continuously cycling on and off. You can get longer run times, less wear and tear, more comfort, more efficiency. Just the kind of thing that I know you've done quite a bit of research on.
Yeah, that sounds really reasonable, kind of the proper right size. One of my pet peeves is right sizing, sizing the capacity for the load. And as you said, not finding ways not to put a head in every bedroom is, I think, generally good, because a head in every bedroom tends to be oversized. Certainly if you've done insulation and air sealing, in my experience. It
tends to be oversized with all the myriad problems that come along with that, including noise and, lousy dehumidification, excessive cycling, all those things.
Yeah. So how about in new construction? I think you work more with existing homes, but do you see, are we at least, I'm very frustrated to see lots of new single family homes or multifamily buildings get built with fossil fuel heating. Are you seeing a shift away from that? Are you seeing success on the new construction side?
We are. It's not universal. Right now, we tend to see a transition from all electric and heat pumps being kind of the realm of the early adopters and the Tesla drivers into a much more mainstream market. So we're seeing more and more homes. I think there's still, for the high-end custom homes, there's still a big appeal of gas stoves, which is something that we need to keep working on. And so the builders do end up running gas service to the house. At that point, they've already invested in all that infrastructure, and they're less likely to go with an all-electric solution. So I do think that cooking ends up being one of the key pieces of this whole puzzle, because it's a part of the it's the appliance that we interact with a lot more than we interact with our furnace or our air conditioner.
Yeah. And on lower income new construction, are you seeing similar progress there as far as electrification?
I think so. Yeah, our local Habitat for Humanity has committed to all electric construction, and we've been working with them on that. They've typically been going with a combination of a single high wall unit plus electric baseboard in the bedrooms.
Okay.
So that's the solution that they've come up with, and our multifamily does also seem to be going a lot in the direction of all electric.
Cool. All right. I think one of my last, we've been talking, I'm looking at the clock. We've been talking for longer than I thought. But one thing I did want to ask you about before we wrap is kind of programs and policies related to electrification, specifically for lower income households. What works now, and or what would you like to see? What would you like to see out there as far as incentives or financing or mandates or
right,
what have you?
So right now, New York State has some really fantastic incentives. Our utilities participate in a statewide clean heat program that provides an incentive of $1,000 per 10,000 BTUs at 5 degrees. So for a system that provided 4 tons, 48,000 BTUs at 5 degrees, that would be a $4,800 incentive. So those are pretty significant incentives, and those are available to people across the income spectrum. New York State has also launched a pilot program through NYSERDA that provides much larger incentives for LMI electrification. It's been targeted at the folks on delivered fuels or electricity, where the highest cost effectiveness is going to occur. And that's actually allowed us to do several dozen homes this last year, and I think we've done a lot of good work through that program. The costs to the state are quite high. A lot of these projects are $15,000 to $25,000 per house, but they do allow us to do full electrification. I think there's a couple thoughts that come up during this process. One is that all these incentives, both the utility incentives and the state low-income programs, they are per ton incentives, and I wonder if that's the best way to calculate these, honestly, because our costs as installers don't increase linearly per ton. It doesn't cost twice as much to install a 4-ton system as it does a 2-ton system.
Right.
Some of the costs are, occur regardless of the size of the system. Some scale with the number of heads or the complexity of it. And then the equipment costs do increase with the tonnage, but not, a doubling in cost per doubling in BTUs. So I think that it would be worth looking into some different ways to calculate those. The other thing that I think we have to really think hard about is how to capture the emergency replacement situation, because the majority of heating and cooling equipment gets replaced on an emergency basis. The system fails. Now we have a no heat or no cool situation, and oftentimes it happens when the customer needs to get that up and running quickly. The state programs require evaluation and approvals, and lead to an extended turnaround time. We can usually find a way to make things happen for people quicker if it's absolutely necessary, but the real key to getting into this is to find a way to decrease the cycle time so that we can offer electrification quickly in an emergency scenario.
Yeah. That's a tough nut to crack, I think. I mean, you think
It's a really tough one, because you want to, design these systems thoughtfully.
yeah.
You want to size them based on envelope improvements that you're going to do. I don't have a good solution, except to encourage people to, kind of get rolling with these things before their system fails.
Yeah, right.
And that's tough when, people are strapped for cash and
Yeah.
are putting these expenses off till they absolutely have to.
Like we all do. In some
Yeah,
way,
that's not an LMI thing. It's across the board.
Yeah.
And so, these have all been kind of consumer-facing incentives, and I am just getting increasingly interested in the idea of upstream incentives where, smaller dollar investments might have more leverage and, might do more to transform the market.
For example?
Well, that idea that Nate Adams had floated, the idea
Okay.
of incentivizing manufacturers to stop producing AC-only units.
Okay, cool. Yeah, it's interesting. I've talked to folks in more urban areas where everybody does have natural gas. Almost everyone does have natural gas. And the number one response I get there is we need cheaper electricity for people that switch to heat pumps. Because especially with low income households, gas is cheaper in most parts of the Northeast right now, at least, if not nationwide. That may change. There's talk about that changing, but it's not a compelling cost picture if you just kind of, without load reduction, if you just switch from gas to electric. So your rural take, I get it. Focusing on delivered fuels, that's definitely the low-hanging fruit right now. And there's a lot of delivered fuels out there. But in Queens, there are not a lot of delivered fuels.
Sure.
There's all these disparate challenges. Do you see any, well, I don't know. Do you have any insights on energy pricing in the future and how that may change or how that may drive demand for heat pumps?
Yeah. I don't have any, kind of deep insights into the direction the market is going. But I do see, ongoing increases in wind and solar that will hopefully be driving the cost of electricity down. I also, it's so hard to know what's going to happen with fossil fuel prices because they're tied up with these, global political things as well as, macroeconomics. I don't really know what to expect with fossil fuel prices. But I think the other thing that I try to keep in mind is that getting to our electrification goals, we need to get working on it really hard right away, especially if we're going to have any chance of hitting our 1.5 or even 2 degree climate goals. But it's still going to be a 20 to 30 year process. And during that time, we have to figure out all kinds of things, including how does the grid handle this increased demand? How do we scale up our contractor network? Right now, we just don't have the trained people to do this work. And so my feeling is that at this point, if we can do these kind of projects cost effectively for people on electric resistance and delivered fuels, let's do that. Let's use that as an opportunity to build up our contractor network, work out the bugs in the technology. Possibly we'll see some cost drops in the equipment along with market changes in the energy costs. And then, 5 years from now, 10 years from now, we can really start to scale and really make deep inroads into the natural gas market.
That's perfect. We wrap up every podcast, almost every podcast, with a question in 5 or 10 years, what if we were to talk again, what would we be talking about? So dramatically improved contractor base, no problem installing heat pumps and is education, is that maybe, well, I'll let you answer the question. In 5 or 10 years from now, what do you think we'd be talking about? Or what would you want to talk about?
Those are two different questions. What are we going to be talking about? I think we're going to be talking a lot about mitigation. I think we're going to be talking about how do we deal with extreme heat? How do we deal with grid disruptions? So that's what I think we'll probably be talking about a lot. I also think that we'll be talking about the next generation of heat pumps, ones that are even more efficient, that use less damaging refrigerants, and that solve problems that current systems currently don't. I think air-to-water technology is going to grow tremendously, and we're going to see, solutions for hydronics that are better than the ones we have right now.
Thank you for listening, and thanks especially to Jon. Again, I'd encourage folks to check out his blog posts on Green Building Advisor. Really insightful and useful, which is maybe even more important. Buildings and Beyond is produced by Stephen Winter Associates. We are focused on making buildings better, more affordable, healthy, efficient, accessible, sustainable, making buildings better all around. Check us out at swinter.com. That's swinter.com. Swinter.com/podcast is where you can find more episodes of the podcast and all the show notes, which we will post some links here for this episode for sure. Also, check out our careers page if you are looking for opportunities. We are definitely looking for help in all our offices: Boston, Connecticut, New York City, and Washington, D.C. I just counted 27 positions on our careers page here now at the beginning of October 2021. All levels, interns, entry-level, senior people. Check it out if you are interested. Thanks again to Jon, and thanks much to the podcast team here: Alex Mirabile, Heather Breslin, Kelly Westby, Dylan Martello, and I'm Rob Aldrich. Thanks for listening.